Hello everyone. Today we want to talk about 6.7 Physical Applications Part 3. And in particular, we want to talk about hydrostatic pressure. So let's make some quick review. We know that mass equals density times volume. Density times volume. And we can write it as m equals rho times v. And force is mass times acceleration. And we write it as F equals m times a. And notice that right here the volume, okay, so let's say we have a volume of a solid. We know that the volume is evaluated by using area times height. Okay, the base area times height. So we have V equals A times H, where A is the area, the base area of the solid, and H is the height. Okay, so we can rewrite this as rho times V. V is AH, so we have rho times A times H. And since force is mass times acceleration, and the mass is rho AH, I can rewrite my force as rho AH, which is your mass, times the acceleration. And in this particular example, we want to use g, the acceleration due to gravity. So rho AH times g. So this is the acceleration due to gravity. Okay, so you can see that I didn't memorize F equals rho AHG. No, instead I use these three equations. Okay, m equals rho times v, v equals a times h, f equals m times a. I use these three equations to create a new expression. Okay, and we will use that later. Now we need one more equation from your high school physics class. That pressure equals force over area. And we write it as P. P stands for pressure. Pressure equals force, F, over area, A. And notice that previously we know that the force can be written as rho times A times H times G. So I will write F as rho A H G, and then divided by the area A. So you can see that this A and this A cancel. We have a new form for the pressure. The pressure is rho times H times G, where rho is the density, and H is the height, and G is the acceleration due to gravity. Okay, so here we have some notes. Hydrostatic pressure is the pressure of water at rest. And hydrostatic pressure has the same magnitude in all directions. Okay, so right here, let me just keep this formula in secret for now. And let's do example 1 directly. Okay, and after finishing example 1, let's see if we can write down the formula on our own. Okay, so in this way, you don't try to memorize this formula and then just plug in the formula. No. Okay, I want to walk you through this whole process. Okay, so let's take a look at example 1. The figure below shows a dam in the shape of a symmetric trapezoid. Okay, so this is a symmetric trapezoid with a height of 10 meters. A width of 8 meters at the base, 8 meters, and a width of 12 meters at the top, 12 meters. Assuming the water level is at the top of the dam, okay, so the water is at the top of the dam, okay, the water level. So that means the dam is full of water. Set up but do not evaluate the integral that represents the total force on the face of the dam. And we want to use rho for the density of the water and use g for the acceleration due to gravity. Okay, so we want to use the method we have been using for a long time, the slice and sum strategy. Okay, and we will need to slice this dam into several pieces. Okay, into several pieces. So let's put the x-axis and the y-axis on the plane first. Okay, on the figure first. Notice that this is a symmetric trapezoid. So I can put the origin right here and draw the y-axis and the x-axis. Okay, so this is my origin. Now notice that you don't need to put the origin here. You can put the origin right here in this corner. You can put the origin right here in this corner. Or you can put the origin right here or right here. It doesn't matter. You can put the origin anywhere. But for convenience, let's just put the origin right here because this is a symmetric trapezoid. Okay, so that means here at the bottom of the dam, it is y equals 0, and the top of the dam is y equals 10. Okay, y equals 10. And we slice this dam into several pieces, okay, into n sub-intervals evenly. Okay, so right here we have this strip. Okay, we have this strip. And you notice that I draw a rectangle instead of a tiny trapezoid. This is because we will pick a sample point right here, yk star, and use the yk star to find the width, okay, to form a rectangle. Okay, and you know that this is an approximation, right? An approximation, and eventually we will take the limit as n goes to infinity. So this approximation will be the true value. Okay, and since we divide this interval into n sub-intervals evenly, and we can call this width, the width or the height of this strip, delta y. Okay, delta y equals b minus a over n, right? 10 minus 0 over n. Okay, so we know that the pressure equals rho times h times g. So let's write down the pressure of this strip. Okay, the pressure on this strip. So we have P sub k. It should be rho. Rho is the density of water, and h is the height of the water right here. Okay, or you can say the depth of the water. So if this is yk star, that means this distance is yk star. Therefore, this distance is 10. Okay, from 0 to 10, as the total length is 10. Subtract. We want to subtract yk star. So the depth right here is 10 minus yk star. Okay, so that's the depth of the water. And multiply by g, okay, rho hg. G is the acceleration due to gravity. So that's the pressure on this strip. Okay, and then we know that the pressure is force over area, P equals F over A. So to find the force, we can multiply the pressure by the area. Okay, so force equals pressure times area. Pressure times area. Okay, so right here, force. Okay, force is pressure. Pressure is rho 10 minus yk star times g. This is the pressure. And then multiply by the area. The area of this strip. Okay, and previously we say that we pick a sample point to form a rectangle, and the area of a rectangle is width times length, right? Width times length. So this is your width, and the length is delta y. So let's say wk times delta y. where wk is your width and delta y is your length. Okay, or you can say it's the height. Okay, now you know we will need to add all these forces together and then take the limit as n goes to infinity. And this is rho is still rho as a constant, g is constant. 10 minus yk star will become 10 minus y, delta y will become dy. Okay, so we need to take care of this wk. So that means we need to find a width. Okay, we need to find a width in terms of y. Okay, because you know delta y will become dy, we want to integrate with respect to y. Okay, so we want to find wk in terms of y. Okay, so there are several ways to do this. Okay, so right here, let me provide one of the ways. So notice that previously we put the origin right here, so that means this point is 0, 0, right, the origin. Okay, and since the base length is 8, that means this distance is 4. That gives me this point 4, 0. Okay, 4, 0. And this is 12. Okay, the width on the top is 12. Okay, because it's symmetric. That means this is 6. Therefore, this point should be 6, 10. So 6, 10. Okay, 6, 10. And why do I want to find these 2 points? This is because right now you have a line that passes through these 2 points. Right? You have this line right here that passes through these 2 points. So I want to find the equation of the line. Okay, I want to find the equation of the line. Find the equation of this line. And since we have 2 points, okay, we have 2 points, we can use the point slope formula. So y minus y coordinate equals slope times x minus x coordinate. Okay, y minus y coordinate equals the slope times x minus x coordinate. And the slope is defined to be rise over run, right? Rise over run. So 10 minus 0 over 6 minus 4. Okay, so let's simplify this. This is y. 6 minus 4 is 2, 10 minus 0 is 10, 10 over 2 is 5, so I have 5x minus 20. So this equation is y equals 5x minus 20. And why do I care about this? Because previously we say that we pick a sample point yk star, right? So that means we already know the y value. If I plug this y value right here, then I will be able to know the x value. Okay, so right here, 5x is y plus 20. That means x is 1 over 5 y plus 4. Okay, 1 over 5 y plus 4. Okay, so that means if I plug in yk star, okay, if I plug in yk star, my xk, okay, my xk right here. So this point, do I have a space? This point right here is x comma y. And when I plug yk star right here, I have 1 over 5 yk star. I don't have enough space. 1 over 5 yk star plus 4 comma yk star. Okay. The reason I want to know the point is because right now the distance from a point to the y-axis is the x-coordinate. So that means from here to here we have 105 yk star plus 4. And you'll notice that the width of the rectangle is 2 times this value because it's symmetric, right? So we can write down wk is 2 times 105 yk star plus 4. Does that make sense? Okay, so that will be 2/5 yk star plus 8. So that will be my wk. Okay, that will be my wk. Okay, so if I put this wk right here, then I can have my formula. So the force is the integral, okay, the integral of rho g, okay, rho g 10 minus y. Okay, 10 minus y is the depth. Okay, 10 minus y is the depth times the width. The width is right here, 2/5 y plus 8. Okay, 2/5 y plus 8. And delta y becomes dy. Okay, dy. From the bottom of the dam to the top of the dam, because the water level is right here, right, to the top of the dam. Okay, so that's your force. The integral of rho g times 10 minus y times 2/5 y plus 8 from 0 to 10. Okay, now the problem asks us to set up only, so that's your final answer. If the problem asks you to evaluate, then you will need to proceed. Okay, and finally, don't forget if you want to answer the question in a sentence, you need to include the unit. Okay, so what is the unit for force? Newton. Okay, good. So right here, know that the unit for the force is Newton. Okay, Newton. Okay, so you can see that this problem is a little bit complicated. This is because we need to find out what the width is. Okay, what the width is. Okay, so if you take a look at the old exams, okay, or the problems on Canvas, you can see that sometimes we have a trapezoid, sometimes we have a rectangle, sometimes we have a triangle. Okay, now for rectangle, it should be really easy, because if you have a rectangle, okay, for example, if you have a rectangle, then no matter where you draw your strip, the width is always the same, right? So the easiest case is when you have a rectangle. Okay, now if you have a triangle, then you will need to use the same method right here. You will need to find the line and try to find out what the width is. Okay, so make sure you practice these types of problems. Okay, now before we finish this lecture, let's take a look at the formula. Okay, so again, right here we have the force. The force is pressure times area. Okay, pressure times area. So let's write it down. So we have the integral, we have rho g, okay, times the depth, okay, times the depth right here. Notice that the base of the dam is at y equals 0 and the top of the dam is at y equals a. So that means the depth of the water, okay, for this strip is a minus y. Okay, so notice that this is the depth. The depth of the water on that strip. Okay, not the depth of the water all the way, okay, on that strip. And then you need to multiply by the width. Okay, so let's use W of y. Okay, because you can see that right here, we need to express WK in terms of y. Okay, so it's a function of y. Okay, and the length is delta y, and delta y becomes dy if you take the limit. Okay, from the bottom of the dam, y equals 0, to the top of the dam, y equals a. So the force is the integral of rho g, a minus y, the depth, times the width, w of y, from 0 to a. Okay, again, please make sure you practice the problems on Canvas, and do not hesitate to let me know if you have any questions. Thank you.